Hello, I'm Mr. Baker. This is the third lesson in my fifth unit for environmental science. Today we're going to transition from talking about the hydrosphere and all the water on the planet to the atmosphere, all the air on the planet. And these are going to interact a little bit, so don't forget everything you just learned, as always in science. Today's big questions we're going to talk about is what is the structure of the Earth's atmosphere, and how does this structure affect regional weather? Right? So the big takeaway is that air is a homogeneous mixture. That means everywhere you go, it's pretty much exactly the same. And that is down to the molecular sampling of it, right? It may smell the same, it may smell different, right? But it's going to have pretty much always 78% nitrogen, about 21% oxygen, and a little bit of other stuff, right? So we've got, depending on who you ask, 0.03% carbon dioxide, 0.9% argon, and we're going to have a bunch of other trace elements or molecules in the air. Now, I know that when we get to climate change, we're going to talk about carbon dioxide and other greenhouse gases. 0.03% may or may not be the most precise number, right? But for the big ones I want you to know, from my class at least, is that nitrogen takes up 78% of the volume of air. Oxygen takes up 21% of volume of air, right? Now, we can also talk about how the temperature changes depending on your climate, depending on the weather, depending on the altitude, so how high up off the ground you are, and the latitude you live at. Right? And temperature is going to be one of the ways that we kind of classify the atmosphere and categorize it, including altitude as well. Right? So what do I mean by when we're talking about latitude? Right? So the sun hits the earth, right? Solar radiation bombards the earth all the time. And in this diagram, that is shown as two yellow circles. Those yellow circles have the same cross section, right? So if you look out over in space out here, they would be the same exact size radius circles, right? I know we're looking at it from the side, so they look flat, but hopefully your brain can work that out. When they hit the curved surface of the Earth's spherical shape, we are going to see that the higher latitudes, those closer to the poles, are going to have that same amount of solar radiation spread out over a larger area. So the same amount of solar radiation is going to hit more actual surface area of the planet than if it was closer to zero latitude, the equator, because that's going to be hitting it straight on. So it's going to be more of a circle instead of spread out in an oval shape, right? This means that towards the center of the Earth, no, let's strike that, towards the equator, we're going to have warmer temperatures in general. Now, this leads to a bigger problem, right? Because it gets complicated, and it gets complicated kind of fast. So, before you look at this big diagram and say, oh, that's a lot of stuff, I'll tell you, you don't need to know what a Hadley cell is. You don't need to know what the Horst latitudes or trade winds are necessarily. I want you to get the concepts here. So, hot air always rises. Warm air is always less dense than cold air. So cold air will always sink, warm air will always rise. So as the solar radiation hits the land and the ocean, that's going to heat up the air above it, right? As that happens, we're going to get these circulations of air, right? And it happens in these six. There are six. There are three on the northern equator, north of the equator, and three on the south of the equator. These six cells, right? And when we combine this with the Earth's rotation, we're going to get some winds. Where we live here in Ohio, right about here, most of our wind is going to come from the west towards the east. If you go towards the tropics, right, between the Cancers, it's going to go from the east to the west. If you go farther south again, down closer to the South Pole, not really close, just closer, we're going to go back to east to west. And then in the poles, We talk about the air going clockwise or counterclockwise, but it's still east to west or west to east. All right. And this all gives us wind, right? It also informs a lot of the local weather because here in Ohio, most of our weather comes from the Great Plains. Along the Pacific coast, though, most of their weather comes from the ocean. In the Rockies, their weather comes from the ocean and the western coast. As we get to the East Coast, however, a lot of their weather comes just south of it because it's going to rise up here and hit this side of the U.S. I hope you can see where I'm pointing. It looks like you can see that, but I want to make sure. So we've got this warm air rising and cold air settling or sinking. This is also going to give us high pressure and low pressure zones. High pressure, you can think of a bunch of stuff pushing down on you, right? That's how atmospheric pressure works, actually. So where the cold air is going down and sinking is a high pressure zone. Where the hot air is rising, it's going to become a low pressure zone. So we're going to have these high pressure and low pressure zones. All right. So remember, if you're in my class, at least, if you're in somebody else's science class, ask that teacher, right? But for my class, you don't need to know the name of these cells. I just want you to know how these concepts will work together and interact, right? And it does get a lot more complicated and it can become really nitty gritty. We're just talking about the bigger concepts here. Now, lately in Ohio, where we live, we have something called the polar vortex that happens, and it's starting to happen more frequently, where this cold air, this polar front on this globe map, moves farther south. And that's when our winters get really, really cold. Usually happens late January into February, sometimes even late March. All right? And it gets really cold because the polar wind that's usually trapped up here in the poles, right, near the North Pole where it's very cold, gets to move down farther than it normally gets down. And that's because this high zone is weaker than it normally would be for whatever reason. Because it's weaker, this hot air doesn't push the cold air back as much and it can go down. Right? You may also hear this talked about as a jet stream movement. It's the same thing. All right, so structure of the atmosphere vertically gets kind of complicated, but there are 5 layers that I want you to know. Troposphere is where we live. It's where all the weather happens. All the cool stuff happens in the troposphere. The ozone layer is right above the troposphere, and it's kind of inside the stratosphere. Above that is the mesosphere, and then above that we have the thermosphere, right? I don't have any great mnemonics to help you memorize that. That's just something you're going to have to memorize. And if you use your hand to memorize them, you can go troposphere, ozone layer, stratosphere, mesosphere, thermosphere, right? You may even, I've seen one of my kids from previous years, I'll put my hand over here, do this, where they go troposphere, mesosphere, stratosphere, or ozone layer, stratosphere, so that they knew that they were together, mesosphere, thermosphere. And there's even technically one above that, but I'm kind of hesitant to lop it in with the atmosphere because it is the exosphere. It's just exo, outside of, and it's effectively where our atmosphere ends and space begins. Something I also want to talk about here is it's not just altitude. Temperature changes depending on where you are in this, all right? So in the troposphere, in general, you're always going to get colder as you increase in altitude, right? And that's this big red line over here. You can see that it has its own x-axis. The y-axis is the same altitudes. And the barriers are across this. So this is actually 2 graphs in one, right? So we see it getting colder as we increase in altitude. But as you go up in the stratosphere, it actually gets warmer again until you hit the mesosphere. And then it starts getting colder again and slightly warmer again, all right? I just need you to know that in the troposphere, it generally gets colder. In the stratosphere, it gets warmer. In the mesosphere, it gets colder. As you increase in elevation or altitude, those mean the same thing here. All right, so we talked about the structure of Earth's atmosphere as a compositional and as a like what is where, right? Diagramming it. We also talked about how that structure tends to affect regional weather for the troposphere. We're going to dive a little bit more into weather, but this is just a brief overview of it. We'll get a little bit more in depth as time progresses. As always, ask questions and keep learning.